Hi students, this is Shivakrishna from Civil Department, Under Engineering College. Today I am explaining the subject in Structural Engineering 1 coming to second unit, that is design of shear and torsion in beams. Here what is meant by shear? The occurrence of the shear in beams is very common in nature. Here, a concrete beam, it is reinforced with longitudinal steel only. So, here we will develop some diagonal tensile stresses that tend to produce cracks. For these cracks, the vertical at the center of the span and become more inclined as they approach the supports, sloping at an angle approximately 45 degrees. Here, the stresses that cause these cracks are known as diagonal tension. In order to prevent this type of failure, additional reinforcement bars are added, which that bars are called as stirrups. These should be placed to perpendicular to the longitudinal axis of that beam. Here, types of failures in the beam. Generally, there are three types of failures occurs on that reinforced concrete beam. That is, one is the shear failure, second one is the flexural failure, third one is the diagonal failure. Coming to shear failure, these shear failures are occurs due to heavy loads. Here, the failure should be occurring at the angle of 45 degrees, and flexural failure, the flexure, it is called the change in bending moment. In this bending moment changes, the flexure will be occurred. Here, the flexure failure see in this figure, the load applied on that particular beam, the beam tend to bend occurs on that particular location. So, here the curved nature will be forming on that particular location. This type of failure is called flexural failure. And what is meant by shear reinforcement? When occurring the diagonal failure on that particular beam, for preventing on that failure, we have to provide the shear reinforcement. This reinforcement should be provided to perpendicular to the longitudinal axis. Why? Because here the longitudinal axis, the main reinforcing bar should be provided on that perpendicular direction. The shear reinforcement should be provided on that particular beam. Here, when the concrete cross section has insufficient area to maintain shear stresses below permissible values, additional resistance to shear may be provided in two ways. One, from shear reinforcement consisting of hoops and stirrups, which may be placed vertically or inclined at some angle with horizontal. With that angle should be provided to 45 degrees from the horizontal section. See here, the figure should be shown as the increasing the number of stirrups or going to the middle of the beam, the spacing of that stirrup should be little much high compared to the edges of that stirrups. Here, number of stirrups should be provided on that particular beam. The strength of that section will be very improved. What is the need to provide shear reinforcement? Here, the shear reinforcement is provided because to prevent sudden failures of that beam. When we are providing the shear reinforcement on the particular beam, to minimize the unwanted failures or minimizing the unwarning failures. Next one, to prevent brittle shear failures due to diagonal principal tension. and to prevent the cracks due to shrinkage. Shrinkage cracks are generally occurred in these types of reinforced concrete elements or structures. This type of shear failure, shear means what? Shrinkage means what? The change in the volume. When we are applying the some temperature or some moisture to that concrete material, the material will shrink on that particular location. In that situation, the failure should be unfortunately occurred on that particular location. These types of shrinkage failure should be minimizing by using the shear reinforcement. And next one, to hold the reinforcement by using the stirrups, the main bars, every corner should placed in the main bars. That main bar should be capable to hold this shear reinforcement need to be provided in that particular beam or column or any structural element you have to provide to hold the main reinforcement. It is used to find the shear reinforcement. And how to design this shear reinforcement? This shear reinforcement also particular design I have to consider here, that is in shear reinforcement shall be provided in any of three of the forms. That is how to place that shear reinforcement, first of all you have to study it. The shear reinforcement should be capable to provide in three ways, that is the vertical stirrups, second one bent up bars along with stirrups, and third one inclined stirrups. Already we are discussed in the last previous slide. Vertical stirrups means the completely perpendicular to main bars, that is called vertical stirrups, like maintain 90 degrees to the stirrups. And bent up bars, along that some of the curtailment will be involved here. When we are providing the main bars to the beam, the curtailment should be provided on that particular location. In that curtailment position, the bent to the main bar with the stirrups. And third one, inclined stirrups. It is completely not a parallel and not a perpendicular. Some inclination will be occurred in here. That inclination angle should be maintained in that particular location. It should be 45 to 60 degrees. Generally, nowadays we are considering the inclined stirrups and that particular location to provide the shear reinforcement on that particular beam. So, how to find the amount of shear reinforcement it should be needed to in that particular beam? By using this formula, we have to find out the how much shear reinforcement should be used on that particular location. The amount of shear reinforcement is to be provided to is determined to carry shear force. How much shear force acting on the pavement, that shear force you have to capable to maintain the shear reinforcement have to provide. Here Vu is equal to Vu minus tau c into B into D. Here Vu equal to ultimate shear force, how much shear force acting on that particular location, that is you have to need to find out on that particular beam. And next one, tau c is the shear strength. For that we have to provide on that particular location how much shear strength will be involved on that particular location. This shear strength you have to find out based upon the IS 456 2000. And next one, B into D, that is a cross section of that element. In that cross section, tau c into BD. BD means the width of the beam and D is the effective depth of the beam. After providing the shear reinforcement, how much spacing on that particular maintaining on that between the stirrups? The maximum spacing of the shear reinforcement measured along the axis on that member shall not be more than 0.75 D. D is the effective depth of that beam. For vertical stirrups and inclined stirrups, it should be maintained as the 45 degrees you have to consider, where here D is the effective depth of that section and spacing shall not exceed 300 mm in any case. The maximum spacing should be provided on that stirrups, it is the 300. It should not be any exceed in any particular situation. And what is the minimum spacing you have to provide on that shear reinforcement means you have to using this formula. It was given by the IS 456 and 2000. This is the formula to find out the spacing of that particular shear reinforcement. What is that? ASV by BSV greater than or equal to 0.4 by 0.87 Fy. ASV means total cross sectional area of the stirrups legs. In 4 bars you have to holding on that particular location. It should be capable to round around the 2 legs. It should be mandatory to provide here, and so says that some of the legs it should be considered here. That is one of the example is 2-legged, 4-legged, 6-legged and 8-legged we have to generally called, and we are generally for 4 bars you have to provide on that each corner 2-legged stirrups it should be maintained, and SV is the spacing of that between the stirrups you have to maintain, and B is the width of the beam, and Fi is the characteristic strength of that reinforcement. Next, coming to torsion in beams. In beams, generally the torsion will be applied. It is very commonly in nature. The torsion means in one side is fixed, another side is moving on that longitudinal axis. The torsion will be applied on that particular location. While applying that torsion on that beam, it will be without warning the beam totally collapsed on that particular scenario. Many types of loadings to produce the reinforced concrete members. The resultant, the torsion may be categorized into 2 types, that is the primary torsion and the secondary torsion. Primary torsion, it is also known as the equilibrium torsion, and secondary torsion it is also called as compatibility torsion. In this equilibrium torsion, it is maintained to static equilibrium. The second one is required to maintain the only compatibility condition between the members. In general, it says that torsion is statically determinate structure. If the equilibrium type and torsion may statically indeterminate structure, should be compatibility model you have to use. When we are using that beam, it is a statically determinate. In that situation, we are using the equilibrium torsion, and it is an intermediate situation. Then we are used to provide compatibility equation. In these compatibility and statically determinate and determined structures held depending upon the support conditions and movement conditions you have to find out. Torsion, it is a major component if it is equilibrium portion, where torsion stiffness of that members have been taken into account for the structural analysis. Detailing of the torsion steel, the spacing of the stirrup should not exceed 1 or 300 mm. There should be at least one longitudinal bar placed at each corner of the stirrups. And when the cross-sectional spacing exceeds the cross-section of the beam, the depth of the beam exceeds 450 mm, in that particular situation only have to maintain the torsional reinforcement or side face reinforcement you have to provide on that particular beam. There should be a minimum. How much area of the torsional reinforcement you have to provide means it should consider as 0.1% of that area of steel. It should be maintained on that particular torsional reinforcement, and it should not exceed spacing of that stirrups, spacing of that members. It should not greater than 300 mm. Next, coming to bond. Bond is the defined as the bonding, the attraction between the steel and concrete. With mild steel, it is the smooth bars. It will be gripping on that the friction developed between that two materials. It should be very high. So that friction you have to find out. So in this situation, the HYSD bars, high yield deformation, it should be plays a very important role for this bond situation. What is meant by anchorage bond? Anchorage bond means with modern high bond bars, the mechanism reinforcement anchorage due to addition of concrete and steel, shear strength of concrete, interlocking of ribs with concrete, it should be maintained very highly. The code specifies that IS 456-2000 specifies that high bond bars, the condition to be satisfied is that average resistance called average bond stress. It is developed along the full length of the bar surface embedded in the concrete. It should be safe and ultimate loads. Design ultimate anchorage bond stress compression is larger by 25%. Why? Because the compression tends to increase the diameter of the bar and tension tends to decrease the diameter of the bar. The end of the compression bar also contribute to transfer the load, and flexural cracks are absent in this compression zone. What is meant by development length? In this development length, the embedded bar should be penetrating in that concrete particular material. The development length should be used. The development length should it is given to full strength of the bar. Okay, in this here the development is the amount of reinforcement embedded in a column to achieve the suitable bond strengths between the steel and concrete. It has a crucial role to play the stability of the structure. It helps to prevent the joint slippage. So the amount of development length required to in a particular case depending upon a variety of factors such as concrete density and steel coating. What is the need to provide the development length? In here, the ensure that the secure the bond between the bar surface and concrete to prevent the slippage failures under ultimate load conditions. The designated development length, the extra length of the bar plays a crucial role in the transferring the stresses developing a one section to adjacent sections. At that critical point like column beam junctions, the additional length of the bar facilitate effective stress transfer to enhance the structural integrity. This is the equation to find out the development length of the bar, that is pi sigma s by 4 tau bd. Pi is the diameter of the bar and sigma s is the stress in bar section considered in the design load, and tau bd is the design of bond stress. This formula should be given by the IS 456 2000. Okay, this development length it should be very highly responsible and play a key role in the jointing of the beam section to column section and extension of beam one plan to another plan and one floor to another floor. It should be maintaining a very important role on that particular situation and scenarios. This bond stress will be developing upon the deformed and compression stage. In the deformation bar, in the deformation situation, the HVST bars used in that particular location, that bond stress values should be enhanced by 60%, and this compression zone it should be used in that the 25% may be enhanced on that particular bond stress values. By applying these values and to multiply the 4 tau bd using the bond stress values, and definitely have to consider and what type of materials you have to use it in that particular location, and for that location for that materials only have to improve that bond stress values and find out the development values. Okay, this is the overview of the second unit of the shear, torsion, bond and development length of the section. Thank you students.